All right, so continuing our notes from yesterday. So again, it's going to be a short lesson today, and we'll pick it up tomorrow after the quiz. So on topic 1, we ended with arithmetic sequences. So today we're going to do the other type of sequence. So if you go to page 4 in your notes, starting with example 6, we're going to look at what's happening recursively from one number to the next. So from here to here, it might be easier to start with the whole numbers. So notice from the first to the second, I'm adding 3, but it doesn't continue adding. This one, it's a multiply sequence, so we're multiplying by 4 to get the next one. And if we tried the previous one, 1/16 times 4 would give us 1/4. 1/4 times 4 gives us 1. So the pattern is that we're multiplying by 4. So again, the recursive, if I want the next 3 terms, so this is a 1, 2, 3, 4, 5. So it wants a 6, a 7, and a 8. So to get a 6, you take the last one over here, which was 16, multiply by 4. So times 4. 16 times 4 is 64. Times 4 again. And we get 256. And multiply by 4 again. And that's 1024. So again, recursively in order, we multiply by a number. And again, just like the other one, it's going to have an explicit, but that one you have to know the formula. So we'll get to that in a second. This sequence is called a geometric sequence. Because each term is determined by multiplying a non-zero constant to the previous terms. So if we're dividing, it also includes dividing, but dividing is just multiplying by a fraction. All right, so here, the number that we consecutively multiply by is called the common ratio. Because to get it, we're going to divide 2 numbers to get that common ratio. All right, so just like we did for arithmetic, we're going to have 2 different formulas, a recursive and an explicit. So the first part is the recursive formula. So reviewing what recursive means. So again, you start with the first one. So we still have a sub 1 is the number. And then we take a sub 1 to get the next term. So you take a sub n to get the next term. You take the previous one, n minus 1, and you multiply that by the common ratio. So labeling stuff, this first one is the first term, whichever one your first term is in the sequence. To get the next one, the one that you want, you take the previous one. So a sub n minus 1 is the previous term, and r here is the common ratio. So this one wants the first 5 terms in the sequence. So write the first 5 terms. So again, I find it helpful to write the spaces 1, 2, 3, 4, 5. So a sub 1 is the first term. So this one goes here, 1. And then to get the other ones, we consecutively multiply by the ratio. So in this case, the ratio is 3. So times it by 3, and we get 3. Multiply 3 by 3, and we get 9. Times 3 is 27. Times 3 is 81. So again, let's prove with this formula. The formula actually flips the ratio and the previous term around, but it doesn't matter because multiplying, you can switch them around. So to prove a sub 5, so a sub 5 is the previous one, well, we'll use this formula. 3 times the previous term is a sub 4. In our picture, or in our sequence, 1, 2, 3, 4 is 27. 27. And 3 times 27 gives us the 81 that we got there. So again, that's just the proof on how we get the number using the recursive formula. So looking at B, again, start with A1. So A1 is 162. This time, our common ratio is 0.5. So we're going to multiply by a half each time. Multiplying by a half is the same thing as dividing by 2. So we're just going to take these consecutively and divide by 2. So 162 divided by 2 is 81. 81 divided by 2 is 40.5. 40.5 divided by 2, 20.25. And then divided by 2 is 10.125. So it's okay to leave decimals like this, but if they were repeating decimals or they got too big, then I would definitely change it to fractions. All right, so that's the recursive idea for the sequence. For a geometric sequence, pretty much the same as an arithmetic. So now let's look at a couple of sequences and tell if they're geometric or not. So for the bottom part, determine whether each sequence is geometric. If it is, then write the recursive sequence. So for it to be geometric, it's got to be a common ratio from one to the other. So here, -2 times what is 6? -2, negative and a negative makes a positive 6, and 2 times 3 is positive 6. So multiply by -3. So I'm going from a positive to a negative. So -6 times 3 is 18. A negative to a positive, so it's got to be a negative again. And 18 times 3 is 54. So because the ratio is the same, then we can say yes, it's geometric. And let's say yes or no over here first, and then we'll come back and write the recursive. So going from one to the other, here I would multiply by 2 to get 8 to 16. And then from here to here, I know it's not 2, because 16 times 2 would be 32. But to figure out the exact number, you just divide. 24 divided by 16 is 1.5. So right there, since those are not the same, I mean, you could do this one too, not the same. We would say that this one's not geometric. All right, so for the geometric one, we write the recursive. A sub 1, the first term, is -2. And then to get every other term after that, we take the previous term and -1. And in this case, instead of adding or subtracting a common difference, we multiply by the common ratio, which is -3. For a lot of these, putting the negative and putting fractions in parentheses is going to be helpful. Not that we need it here, but once we start making the explicit formula, we're definitely going to need the parentheses. All right, a geometric sequence is an exponential function. And this is the unit that we're on, is exponentials. And later on, we're going to graph it. It's going to look like this, r to the x. R is going to be your common ratio. Right now, we're not graphing it. But this is what we're getting into. This is what this unit is. Unit 9 is exponentials. All right, for example number 9, determine whether each sequence is arithmetic or geometric, or neither. So arithmetic means it has a common sum, and geometric or difference, and geometric means it has a common ratio. So we got to check both of them here. So for A, first, let's check to see if it's a common difference from one to the other. So 6 plus 8 is 24. And 24 plus 12 would be 36. So right there, we know it's not arithmetic. So now we got to try geometric. So 16 times what is 24? So the better way to do that is just to divide. 24 divided by 16 is 1.5. So now we got to check the other ones. 36 divided by 24 is also 1.5. And 48 divided by 36, checking that, is 1.5 as well. So since the ratios are the same, we can say that this one is geometric. So then it also says make a recursive rule for this one. So if it's geometric or either sequence, we always start with A1. A1 equals the first term. First term is 16. And then for the rest of it, to get the next term, you take the previous term and multiply by the common ratio, which the common ratio here is 1.5. So on the formula, it writes the common ratio in the front. It's the same thing. It doesn't matter. Commutative property says you can move it around. All right, looking at B, if we look at the difference from one to the other, from 1 to 4, we would add 3. From 4 to 9, we would add 5. From 9 to 16, we would add 7. So right there, it's not the same. So again, I know it's not arithmetic. But then I got to check the product. 1 times 4 is 4. But then if I do 4 times 4, I would get 16. To get the 9, 9 divided by 4 is 2.25. And right there, I know it's not the same. So it's not geometric either. So we just say that this one has neither sequence, arithmetic nor is it geometric. This addition part where it goes up by 2 each time, that's actually quadratic. But we're looking for arithmetic sequences, which are linear, and geometric sequences, which are exponential. The quadratic and the cubic, we don't classify as one of those. All right, looking at C and D. For C, what do I have to do to 23 to get 17? I have to subtract 6. So now we check the other ones. 17 minus 6 is 11. And 11 minus 6 is 5. So right there, I know it's arithmetic. And I can write my recursive formula. So I start with A1. First term, 23. And then for the rest of it, to get the next one, A sub n, you take the previous one, A sub n minus 1, and you add or subtract the common difference, and the common difference for this one is negative 6. So I subtract 6. So again, that's why I multiply or divide or add or subtract at the end, because adding and multiplying can go in the front, but subtracting cannot, because it is not commutative. All right, and then the last one, just looking at it, I know it's not an addition pattern because they alternate positive negatives. So I'm going to go straight to multiplication. So negative 4 to get 8, I would multiply by negative 2. 8 to get negative 16, I'd multiply by negative 2 again, negative 2 again, and negative 2 again. So this is my common ratio this time. Since they're all the same, this would be geometric because it has a common product. And we say A1 starts at negative 4. And to get all the other ones, to get the next one, you take the previous one, A sub n minus 1, and you multiply by the common ratio, which is -2. So in this case, you don't need the negative, but we're going to see in just a second that you really should have your negative there. All right, and then the bottom part, this one gets into recursive formulas, explicit formulas. So just like we had before, geometric sequences also have explicit formulas, just like the arithmetic ones. So to get a sub n, you take the first one and you multiply it by the ratio to the n minus 1 power. So a sub 1 is still your first number in the sequence, and r here is the common ratio. All right, so find a sub n for each geometric sequence. So a sub 1 is -4, the common ratio is -2, and n is what we're trying to find. So here we're trying to find a sub 8, the 8th term in the sequence, because that's what the n is. So a sub 8 equals -4 times r is -2, and to the exponent n minus 1, n is 8, and I'm going to subtract 1 from it. Notice I put parentheses around the -2. It is critical that you have parentheses there for negatives and for fractions, because if you type it all in the calculator at once without parentheses, it's going to give you the wrong answer, because it does order of operations. But simplifying this in order, we would do the exponent first, which is 7, and then we would evaluate that part. Again, you could just type all this in the calculator at one time. Just be very careful on how you type it in. So if I type in the -2 to the 7th with parentheses, I get -128. And then multiplying -128 and -4, I get that a sub 8 is 512. So again, this is the important part for the negatives. In order for it to alternate between positives and negatives, you have to have the parentheses around it. Otherwise, it's not raising the negative to the exponent. All right, and then at the bottom, same thing. We're trying to find the 8th number in the sequence. Or not the 8th number, sorry, the 6th number in the sequence, but we need to make the equation first. So I'm just going to copy the formula down again. A sub n equals a sub 1 times r to the n minus 1. So we're looking for the 6th number in the sequence. Our first term is the 800 times our ratio is the 1/2. So again, it needs to go in parentheses if you're going to type it all in at once. And then n is 6 minus 1. These two will always be the same. The exponent and the subscript are always the same number. So a sub 6, 800 times 1/2 to the 5th power. So again, typing all this in the calculator at once with your parentheses around the 1/2 is going to give us a sub 6 equals 25. So again, that's all it wanted us to do there. All right, so the last page, again, we're on topic 9, or unit 9, topic 1. So here, example 11 says, Sarah posts a joke on her social network page, 4 of her friends repost joke, and 4 of their friends repost joke, and so on and so on. How many will post on the 9th round? So we could make this go 9 rounds. So A1, A2, all the way to 9. But it's probably better just to use an explicit formula to jump straight to the 9th. Okay, so A1, so Sarah herself is not A1. It's her 4 friends that post that are the A1, the first round. So the first round, 4 people post a joke. And then for the next round, 4 of each of their friends post a joke, so times 4 would make 16, and so on and so on and so on. So if we make a formula, so remember this is multiplying, so it's a geometric. So we're going to use the formula a sub n equals a sub 1 times r to the n minus 1. To get 9, we're looking for the 9th one. To get a sub 9, we can take a sub 1, which is 4, and multiply that by the common ratio, which is each of their 4 friends. So common ratio is 4 to the 9 minus 1, because 9 is the round that we're looking for, minus 1, because that's what the formula says. So here, this is 4 to the 8th, and I would just type this all in the calculator at once. We don't need parentheses here because it's not negative or fraction, but again, just out of habit if you want to put parentheses around the base. So typing this all in, we get 262,144 people would post the joke or have posted the joke on the 9th round. Okay, so again, here the starting one is the a sub 1. Sarah herself is not the round one. That would be like a0, the previous one. So you start with the number of people that post it, and then you just multiply from there. So over here would be that number on the 9th round. All right, and then we'll just do number 12 today. We'll save 12b and 13 for tomorrow. So here looking at 12, this one wants us to write an equation for the nth term. So again, nth is an explicit equation. So let's write the explicit formula. A sub n equals a sub 1 times r to the n minus 1. So a sub 1 is 0.5. So I'm going to write it as 1/2 times r. Well, I got to see what these are going up by. So what are we multiplying consecutively by to get to the next one? Looks like we're multiplying by 4 by 4. So r is 4. And we do n minus 1. So again, the fraction is there, so I'd put the fraction in parentheses. We don't need parentheses around the 4 because it's not a negative number. All right, our final example here is number 13, and this one's going to require you to do quite a bit of steps. So notice here, this time it doesn't give you the a value. So remember our formula for the nth term is a sub n equals a sub 1 times r to the n minus 1. It doesn't give me a 1 or it doesn't give me r, so I actually have to find both of them here. It gives me 2 numbers in the sequence. So there's a couple of ways you can do it, but I'm going to show you the algebraic way first. So the first thing you need to do is use the formula. So step 1, use the formula here and solve for a sub 1. And you usually want to do the one that comes first in the sequence. So the first term out of these 2. So the first term is the one that comes first is this one. So that's the one we want to use to solve for a1. So here, step 1, we're going to plug in what we have. So a sub 3 equals a sub 1 times r to the 3 minus 1, because n is 3 here. Well, a sub 3 is negative 48. So negative 48 equals a sub 1 times r squared. So again, the goal here is to get a1 by itself. So to get a1 by itself, we just divide both sides by r squared. So a sub 1 equals negative 48 over r squared. Now we want to use this with the second part, the second number in the sequence, and plug it into the formula. So substitute A1 into the other formula. So we didn't make a formula for this one. So step 2, we have A6 equals A1 times R to the 6 minus 1, because n is 6. And then substituting and simplifying, A6 is 3072. A1, I want to plug in this that I have over here. So negative 48 over R squared. And I'm going to multiply that by R to the 5th. All right, so this is like the fraction. If I do top, top, bottom, bottom, 3072 equals negative 48 R to the 5th over R squared. So you have to remember your properties of exponents here. When you're dividing two numbers, you subtract their exponents. So I would get 3072 equals negative 48. R5 minus 2 is 3. And that's why we picked the smaller one to solve for, because if we did it the other way, we'd end up getting a negative number here, a negative exponent, and then that would require more work. All right, so solving for R, we divide by negative 48, divide by negative 48, and in your calculator, dividing this by negative 48 is negative 64 equals R cubed. And think back to rationals, or to radicals. To get rid of a cube, we have to cube root both sides. So we take the cube root of negative 64, and we get that R is negative 4. So here, now we found one of these values in the sequence. So now we got to go find the other one. So step 3 is to take that number and plug it in to the one we got from step 1 to find A1. So substitute R to find A1. So step 3 here, A1 equals negative 48 over negative 4 squared. So negative 48, negative 4 squared is positive 16, because a negative and a negative make it positive. So here we get that A sub 1 is negative 48 divided by 16 is negative 3. So that's the number that goes here. So now we have everything that we need to make the formula. So step 4 is to just write your equation, write your rule. So write the rule. So here, A sub n equals A sub 1 was negative 3 times R was negative 4, and we leave our exponent as n minus 1. So this is what the question asks for, but we don't have any information to start with, which is why we had to do all the other stuff in between. All right, the other way that I've seen is with the little spaces. So 1, 2, 3, 4, 5, 6. And you put this one in the third space, negative 48. And you put this one in the sixth space, 3072. What you cannot do is you can't just subtract the 2 and then divide by 3. That would be an arithmetic sequence. It works for arithmetic. It does not work for geometric. There is another way you can figure out how to go from one to the other and then work backwards, but it does require what we do here. So here, if you're taking 1, 2, 3 steps, you know you got to multiply the number by itself 3 times. That's the cube part. So then you can find that number and then just work your way backwards to find the A1 once you get that number. That's another way if you prefer that way. It is a lot of guessing and checking to see what that number is going to be though. So you have a couple of examples like that on the homework at the very end of the geometric sequence part.